Let's now talk about PowerFlow records integration. By PowerFlow records integration, we mean how to connect an existing OpenIPSL model to the record structure that we are proposing here. This is how the record structure looks like. So you can observe here that it's composed of a set of records and nested subpackages. But the fundamental building block of this PowerFlow data container are Modelica records. Modelica records are data structures that stem from the object-oriented nature of the Modelica language that have the special property of handling information of a model within a class. And in our case, the record structure enables us to control all PowerFlow variables with a single attribute of a given class in a model. So that would allow us to change PowerFlows with a single click. The PowerFlow structure will be created automatically by a Python script called create_pfrecords. The Python script can be found in the GitHub repo accompanying this tutorial. And basically what you have to do to run the records file, to run the record creating script is really simple. So first you would locate your SMIB folder, you will place your existing model inside a subdirectory. Then you can see how this is done in our repo, where we have included an example of the SMIB developed with OpenIPSL 1.5.0 and with the new version. Each of these is located in a different directory. And after that, once your model is there, you just run the script, as we will show later. That will create the structure and will automatically include it into your model. However, there is no free lunch, so we have to link the PowerFlow variables to the model manually. And that's the price that we have to pay for using this convenient record structure. Some closing remarks regarding the type of bus that you use in your model. So in the SMIB, we have used this black bus model. So we don't necessarily have to pass the PowerFlow information to these buses. But so we have only to fill the PowerFlow data blanks in loads, generators, and transformers. However, if we use bus X, that is this blue bus that is more aesthetically appealing, then we have to provide the PowerFlow variables to buses, loads, generators, and transformers. So let's get started and create the PowerFlow record structure and link it to our model. Okay, so here we are in our SMIB package folder, where I have copied and pasted the pf2rec folder from the GitHub repo. And the next thing that we have to do is to open a command prompt and launch the Conda environment that we created while installing Gridcall. So let me enlarge a little bit this window, and let's activate that environment that was named SMIB tutorial. So we activate this, we change our directories. So remember that this is not as convenient thing. This is not as easy if you are using a virtual machine as I am, but basically you can just right click here on the Windows Explorer navigation menu and you copy the path here. But if you are using a virtual machine, then it gets more complicated. Well, once you navigate inside this folder, you can open a Jupyter Lab, and from here the steps are pretty much simple. So let's wait for a minute until it opens. And once we're here, let's create a new notebook that we will call create_pfrecords. create_pf_records. So once we are here, there are a few steps that we need to perform. So the first one is to import everything from the pf2rec subfolder. So from pf2rec, import everything. And to handle the paths, we will use the OS Python library. So that's everything we need to do regarding the imports. But since we will be working with OpenIPSL version 2, then we can define a variable here just to have the version in some place. Okay, so now we need to create the PowerFlow record structure. We need to get the absolute path of the data where the folder where the model of the data of the model is contained. So that is this folder, this SMIB folder. So for example, we need to get this path, but as an absolute reference within the operating system. So to do it, we will use the OS get current working directory CWD function. So if we just call it here, we observe that it returns us the absolute path, and it automatically this OS library is cross-platform, so it works really well, and it manages the special characters for path in Windows, Linux, or Mac OS perfectly. So we would like to get inside this folder, we would like to get the directory of the SMIB subdirectory, the path of the SMIB subdirectory, sorry. So we will do OS path join, and if we run this, we'll see here that basically it constructs a path with these two, taking the second argument as a subdirectory. Then we would like to store this into a variable called data path. And just to make sure that this works on any operating system, we can just say, okay, the path that we're passing here, convert it to an absolute path. So we encapsulate all of this as follows, and we get our data path variable. Besides that data path variable, we also need the path to the mo file where the model is declared. So that is not the package.mo file, but the SMIB_base_case. And what we will do here is to create a new variable, path.mo file. And if you notice, this file is contained within a subdirectory. So it's OS path join. So inside data path, we would like to have SMIB base case.mo. So just to make sure this is an absolute path, we will encapsulate it as well inside an OS path apps path call. And that's it. Those are the two paths that we require for creating the record structure. The path to the mo file where the model is defined, and the path to the folder where our package has been saved. That in this case is SMIB. Now we can call the create pf records function. So there are a few arguments that we need to pass to this function. The first one is the name of the package, that in our case is SMIB. The second one is the path to the mo file. The third one is the path to the data folder, that in our case it's a variable data path. And the fourth one is to indicate the OpenIPSL version. So this defaults to 1.5.0, but in our case, since we're working with 2, we will be explicitly passing a keyword argument as follows. So now we are ready to execute this cell, but I would like you to have a look into what this does. So if we run this cell here, then we will see that well, version is not defined. Probably I need to run this cell again, or it was 2 double underscores. So let's run this again, and you may or may not have observed that by executing this cell here, a new folder called pfdata has been created inside the package directory SMIB. So inside pfdata, we have a bunch of subfolders and .mo files that actually represent the data structure for the PowerFlow records. So to have a look into it, let's go to our to Daimola and refresh our model. So here we go into the SMIB exactly the same system, and probably I'm doing something wrong. Let me refresh it. Yeah. And yeah, so here at the bottom we have now a sub package that has been automatically linked to the model by this function as well, that is called pfdata. And pfdata has a bunch of sub packages: bus data, loads data, transpose data, but they represent the structure that on which we will aggregate different PowerFlow results. So the only thing that we have to do to our model is to drag and drop one of these, the first record that appears here, the PowerFlow. We will drag and drop it to our model. We place it somewhere on the canvas, and we can change the name for convenience to PF. So let's save our model, and that's pretty much what we have to do to link the PowerFlow record structure to our model. Then in the next part we will generate PowerFlow results using grid call.